Here we go. What do you want your IP SAN to do? Let's get it to work. Okay. The obvious answers are you want to centralize your storage. That's the main thing that drives the IP SAN standard that's out there. It's coming into play and being driven by virtualization of servers and the requirement to have central repositories rather than individually held areas. It's also capturing the fiber channel market, particularly in the SMB and the SME arena. The other reason is the concept of IP SAN products. They were visualized as having embedded features rather than having to have multiple hosts running backups or snapshots. And so a lot of people look towards IP SAN to take care of simple operations such as thin provisioning, deduplication, mirroring, and we'll touch on these a little bit as we go down. And the last thing, and these are universals that have been around in storage forever. What are they looking for? Now high availability, high transfer rates, high I/O. Tiered storage is the latest technology where you can move data between different performance metrics of storage. General file serving, and the number one thing in the history of the world is budget. How much can I spend? How much do I get?
And what's key there, Dick, I think we need to differentiate between the we need as a company versus the I want in identifying the initial SAN requirements so our customers can eliminate costly post-implementation gotchas.
Yeah, we get it. We run into that an awful lot. The wish list isn't exactly what the real list is going to be. All right. Now I mentioned earlier, we're going to just touch briefly on the different features that people are looking at and how they impact the subsystem in terms of performance, as well as the backside reality of sometimes implementing these things. Thin provisioning, without getting into technical discussions, it's the ability to present a high-capacity drive to an operating system with the reality that it's using much less storage capacity within the storage subsystem. So you can present a 4 gigabyte drive or volume to a system, in reality be only using 1 gigabyte or 1 terabyte of data. The advantage is actually very limited to this feature. The database applications are the number one product that takes advantage of this capability. Whenever you set up a database, it says, how large is the database? And you'll say 1 terabyte. The problem you have is when you hit a 1 terabyte boundary, and you need to recompile the entire database to expand it beyond that. This is time consuming. It brings about downtime and a number of other things. So Thin allows you to set an artificial limit with a plan for 3-year forecast, 4 terabytes. And when you hit the physical boundary of 1 terabyte, you can expand it. And ultimately 4. So this is a great. The reality is, thin provisioning is probably one of the biggest mistakes to make in a database environment. The name of the game in a database environment is speed. People purchase high-speed 15K RPM SAS drives. People are using pinpoint technology, using solid-state disks to increase their performance. Right? Speed, speed, speed. What happens in a thin provisioning environment is you start out with a single metric size of 1 terabyte, and down the road you'll expand it to another half a terabyte, and then you'll add another 1.5. What happens is this space is being taken up within a pool, within a giant RAID space of redundant data, and other people are using the same pool of data. But ultimately what happens is you create tremendous fragmentation as you're adding in the different thin sets during the expansion process. So the number one thing, I think we're all very familiar with this, a fragmented drive is a very poor performing drive, a noticeably poor performing drive. You have problems with defragmentation at this point. We're not dealing with a 120 gigabyte drive, and you can defragment that puppy in an hour, you know, and go about some other chores, tasks, take a long lunch. We're talking terabytes, and terabytes can take days to defragment. So defragmentation program running greatly impacts performance. All right, you get some performance segmenting, but you're also losing an awful lot of cycles in I/O by constantly monitoring and defragging your file system. One of the other things that happens with thin provisioning, the thin feature is not necessarily extended or supported with other features that are embedded, mirroring, replication, snapshots. You can't run a thin volume, or you can do an asynchronous replication of a thin volume. So you have to look at things on balance of what features you need to use with it. What's your performance on this sort of thing. Bottom line, database apps have an admissed high performance penalty, and in general, and this is a feature that people don't understand, general files or anything that you present in our IDs and products can always be expanded. We have things that come, but if you have a 2 terabyte volume and you load it up, we can expand that with terabytes in order to do it, and it's a better practice to expand your volumes rather than artificial limits being placed within your storage.
Dick, with the advent of VMware and Xen offering thin services, thin provisioning services, so if server virtualization is in play, does it make sense to put those services on the host or penalize the SAN performance for all the hosts? So where would be the best, I guess, you know, application for thin? Question number one. And question number two is, what are we doing from our end to solve that problem?